Hi, now I'm going to talk about the dataset analysis and visualization that we have done for the plot CW25 biomedical dataset. Uh, so let's start. Here I'm just loading the dataset. This entire analysis has been done for the training set. Okay, so first visualization that we have done is any attack distribution, how any attack are distributed. Here we can clearly see that 0 is having the maximum count, thus the dataset is quite imbalanced. Next analysis that what we have done is a token length, how the token length is varying. So as we can clearly see, the acronyms are having the shorter token length, whereas the long forms are having a longer token length, and they vary a lot. Thus, we need to use, thus it clearly shows that we should use models such as LSTM and transformer that can handle longer token as well, long-term dependencies that it can handle. Next analysis, what we have done is the most common abbreviation that we are finding in our data set. So here we found tilde is the most common abbreviation, thus pre-processing quite important. We should remove these kind of things. Next is the heat map and the long forms and how they're present in the data set. So what we are doing over here is we have taken only 5 abbreviation, and for those 5 abbreviations, we are having multiple definitions. So just we are seeing what are those definitions are. So for example, if we talk about HR as one of the abbreviation, the most common definition of it is hazard ratio, but that is found 17 times. But heart rate is one of the definition that is used 2 times. So here we are seeing the ambiguous abbreviations. So thus context also matters, in which context that abbreviation is used. So yeah. Next, we are just looking into the real abbreviations and the long forms, a simple thing. And in the last analysis we have done is PUS stack distribution by the entity types. So if we talk about, let's suppose noun, right? So noun is mostly found in middle of the long forms, whereas if you talk about adjectives, it's mostly found in the beginning of the long forms. So yeah, that's all analysis. That's all the analysis that we have done for the data set visualization. Thank you. Hi, now I'm gonna walk you through the experiment one. In the experiment one, we are playing with the different tokenizations. We are using total 4 different types of tokenization in experiment one, that is random matrix, glove, fast text, and the board embedding. So let's start with the code. Here we are loading the dataset as usual. Here we are just building the vocabulary. The embedding, then here I'm initializing the embedding manager. What embedding manager does is that it handles loading all the embeddings and creating that random matrix as well that we are using later on. Here we are loading the train test and validation. Here I'm defining the entire model, all the model definition, the config of the model. Um, then the definition of the model is over here. Then this is the training loop. And that training loop is over here. Now this function and the next function takes care of creating the F1 score, precision, recall, confusion matrix, everything that is required to evaluate how good the model is. So once we do that, now this is the main function that runs the experiment. This function takes the name of the experiment, how I want to name this experiment, the embedding matrix, the optimization of my choice. In this experiment, I'm using Adam. And is this embedding transformer or not? Because transformer-based embedding needs a different special handling. So just a placeholder for that. So while I'm running the experiment one, I'm just playing with this, I'm just calling this function only. So now let's go down. So here I'm running the experiment one. Here I'm passing the name of this experiment and the embedding matrix. So this is how the experiments, the output looks like. This is the training log, everything. Now we get the validation set performance, all the thing, precision, recall, F1 score, support, everything is there. And then I'm also printing where the model is misclassifying. So it was 0, now it was printed as this. So all the things are over here, and the counts, right? How many times it's getting misqualified. Similarly, it's just printing the sample token as well over here. Now, after printing all the sample tokens, I'm doing this for the test as well. So here, this is for the validation, the heat map. Now for the test set as well, I'm doing the same thing. Precision, recall, everything, and then where the token is misclassifying, and the source sample tokens, right, where it's misclassification is happening. Similarly, it's done by the glove, passing the matrix and everything, and for the fast text, and for the boot. That's it. That's how we have structured experiment one. Thank you. Hi. In the experiment 2, we are doing the sequential comparison between 4 different algorithms, that is bidirectional LSTM with BERT encoding, CRF, using different embeddings, BERT and BioWord. Uh, so the first setup that we have is a bidirectional LSTM with BERT encoding. This is the same experiment that we run in experiment 1. So yeah, because it was the best performing in experiment 1, we are doing in experiment 2 as well. So yeah, it's the same thing that we saw in experiment 1.
Hello, myself Akash, and I'll be explaining the CRF implementation in our project. So here, while implementing the CRF, we are using word-to-vec embedding as well as TF-IDF tokenizer in order to get the features of all the tokens in the dataset. So here we are configuring the word-to-vec embeddings. This method will load the data into the a variable. Apart from that, we are also implementing a custom vocabulary for the dataset. This section explains the this section trains the data, trains the model on the dataset, and also we are using a randomized search CV in order to get the best configuration of the hyperparameters, that is C1 and C2. And these are the results which we are getting while we are training the model on the randomized search CV library. So we'll now next in the next section CRF, we are training the actual CRF model on the entire training dataset, and this training process starts in this section. And here we can see the test results of the CRF model, where we are getting 7.772 F1 score, precision at 0.80, and recall at 0.741. Thank you.
Hello, sir and ma'am. I'm Arshil Lamini. I'm doing the NER project with you. So for this project, I've chosen the BioBart pre-trained model. So this is one of the sample output of the BioBart fine-tuned model. So now I will delve into the coding part. Here I'm importing all the necessary libraries. Here I'm loading the dataset, sorry, NLP, plot CW25, NER dataset. Next, have written a function to map labels to its IDs. Next, I've implemented the tokenization. One of the important part of tokenization is to um, label the spatial tokens like CLS and SCP into -100 so that these tokens are considered in the loss back propagation process. Here is the loss function. I have also applied lots of loss functions to find the best possible outcome. Next, here is the optimizers. I've tried AdamW, Nester of RMS Prop, and Adam. Next, here's the training loop. It goes on like this. Here's the evaluation phase. In the evaluation phase, we have used the SegVal F1 score, which was required by the project document. I've also done a little bit of deployment part. Here I'll show you the demonstration of deployment part. I've uploaded the code in Hugging Face and then a Hugging Face space. I'll throw a test query and see the output. You see the ISU is recognized as acronym, the HO is recognized as acronym. It's doing quite good. I've also prepared some other queries, some rare queries. And it's running, as you can see. It's identifying the acronyms quite well. The long forms, continuation of long forms is doing quite well. Thank you very much.
Hi there. I'm just going to explain about the different kind of optimizers as well as the loss functions. So we have every function written here in mainly here. So and we are just calling as a config file below. So the first one like which we did with this atom optimizers, atom W optimizer. So it is very fast convergence and it's giving a good results also. The second one which we did with is like n atom. So basically it is combining atom as well as Nestro momentum. So it is actually this is the best. I mean, like with the optimizers, which we got a great results for this NADM only. The third one, which we did was with RMS probe. So compared to other things, like it is giving a very less results. So basically, like for a noisy gradient, like it will be because as it is averaging, so it will be good. But here, like it is not giving that good result. The fourth one which we did is like this is the one which we did is HGD Nestro. So it is HGD with the momentum Nestro this momentum. So it is also good. The only problem with this one is like it takes too much. I mean, comparatively to Adam, it's like a little bit too much time to convergence. So this is for the optimizer part. The second one which we did is with this different type of losses. The first one which we did is with cross entropy loss. So basically like it will like as the mainly like it will all fit for basically for if the major data is there, like it will all fit this cross entropy loss. So that's why like for a rare conditions like we use focal loss. So basically it will check for the hard instances, so whatever the lessly non attributes, so for that it will cross check it and it will give a high value for that one. So we did with the focal loss also, and also like we did with label smoothing. So label smoothing, like it's a smooth gradient, so like it is like a it is actually giving the best performance. So basically we did three things. The one is with the cross entropy loss, the focal loss, and the third one is like with this label smoothing, and we combined together with the cost entropy with the label smoothing, that gave the highest result also. So these are the result for those things. So mainly for everything, like we put it in config and we ran together all these things.
So this is the deployment section of the APIs where we are exposing the endpoints for multiple purposes through which the user can use the model's prediction ability. So here we can deploy and use the server like this. So if we call this API slash models, then it should give all the models, a list of all the models which have been deployed in the library. Then there is another endpoint which is exposed to get the specific output of this related model. So here we are passing one string with the along with the model name, and when we send the request, we can see the API is giving the response output as a response in this JSON format. Thank you.
This is for the stress testing. So for this one, I'm using a locust one. So here, like we have the API. So I'm just testing with 100 concurrent users with the ramp up speed of I mean 10 users per second, and I'm just running it for 10 seconds. So you can see like now like the APIs are hitting, and you can see the result here. So totally like for 10 second 465 request hit, as well as the request per second is 32. So this is for this 10 seconds with 100 concurrent users. The maximum which we tested is with the 9700 concurrent users for 10 seconds. It is working fine. More than that one, like we are getting an failures.